dear students, it's noisy signal. Is it clear now? Just do reply. Hello dear students, it's noisy signal. Is it clear now? Just do reply. So I think now voice is clear and audio video both are clear, guys. Whether yes sir, clear voice. Okay. So let's start, beta. In the last class we have seen about the even signal and odd signal, and we have also concluded that in the even signal Fourier series will contain only cos harmonics, and in the odd signal Fourier series will contain only sine harmonics. As far as non-zero Fourier series coefficients are concerned, if the signal is even signal, then we have a A1, A2, A3 all are non-zero, even A0 also can be non-zero. But if the signal is a odd signal, it will directly make your A0 value, average value 0, and the remaining B1, B2, B3 all coefficients can be non-zero for the odd signal, whereas AN completely 0. Yes. Now student, going forward we will discuss today's class very important symmetrical condition, that is known as half wave symmetrical condition. So just make a heading, half wave symmetrical condition. Half wave symmetrical condition. Half wave symmetrical condition. Half wave symmetrical condition. Okay, chaliye. So dear student, if I talk about a half wave symmetrical, a signal is said to be half wave symmetric signal if it satisfies this condition xt equal to minus x of t plus minus t by 2. Xt equal to minus of x t plus minus t by 2. Xt equal to minus x of t plus minus t by 2. If any signal which satisfies this condition will known as half wave symmetric signal. Now student, mathematically it is very tough to check every signal whether it satisfies the half wave symmetric or not. So I will create an amazing short trick for you guys. The short trick is again a unique part that you will never find in textbook, reference book. So student, I will make the short trick and I will make the examples of waveform also for you, so you will get the clarity. But the condition is, if the signal which is a periodic with the fundamental time period capital T, where capital T is fundamental time period, where capital T is nothing but FTP. So if it is noted that the fundamental time period capital T, and if signal satisfy this condition, then the signal is HWS, and once the signal is HWS, for HWS signal, average value will be always 0. Average value A0, average value A0 will be always 0. Will be always 0. We are writing the property for which signal? For HWS signals. About the HWS signal. HWS signal in the Fourier series representation of HWS signal, the Fourier series representation of HWS signals contain only odd harmonics. Contain only odd harmonics. Contain only odd harmonics. It means all even harmonics will be 0. Here all even harmonics will be 0. All even harmonics will be 0. All even harmonics will be 0. It means if any signal which satisfies the HWS condition, this is also known as HWSO. Why I am denoting HWSO? Because here we have a minus sign. So HWSO means minus sign is here. So HWSO. This O is nothing but odd signal. ये जो odd है, ये odd signal के बारे में नहीं बता रहा है. ये symmetrical condition HWSO लिख रहा हूँ because we have a negative sign here. It doesn't mean कि signal odd signal है. It doesn't mean कि signal odd होगा. Is it okay? चलिए. Now again I am repeating. If a signal which satisfy the HWS condition, then it will contain only odd harmonics. It will not contain any even harmonics. All the even harmonics will become 0 and average value will also become 0 if the signal is a pure HWS signal. If the signal is a pure HWS signal. Now, what is the meaning, sir? Pure HWS, because sometimes signal may satisfy hidden symmetrical condition, and what are the hidden symmetrical condition, that I will explain after the 15 to 20 minutes. But right now we will discuss about what is the actual symmetrical condition and what are the modification if we will do, then it will satisfy the hidden symmetrical condition. Okay. So, student, here I am giving you one table. You should make a table. This is the HWS criteria, where I am just giving you a short trick. If signal satisfy any criteria, so, student, what I am writing here? I am writing here the HWS criteria. Here we should write T equal to 0 amplitude, and here I am writing at T equal to plus minus T by 2. So, student, if we have a amplitude criteria, then what it will be? At T equal to 0, if signal is having the amplitude plus A, then at T equal to plus minus T by 2, the signal should have the amplitude minus A. At T equal to 0, if the signal is having the amplitude minus A, then here it should be plus A. Now, student, here if I talk about edge criteria, what is the edge criteria? At T equal to 0, if the signal is having the positive edge of A amplitude, then at T equal to plus minus T by 2, the signal should have the falling edge. If falling edge and this is a rising edge satisfy, then we will say that the signal is HWS signal. Students, first of all complete this table, after that I will give you multiple examples. So, all the criteria will be clear to you. At T equal to 0, if the signal is having the falling edge, then here it should be have a rising edge. Now, here if I talk about the slope criteria, so at T equal to 0, the signal should have plus K slope, then here we should have the minus K slope. If here the slope is minus K, then here should be the slope will be plus K. I hope this part is clear to you, bachcho. I hope this part is crystal clear to you. Now, student, how to check? If a signal which is satisfy any condition out of these three, if signal satisfy any of the one condition, then we will directly write that the signal is a HWS signal. And if examiner will ask about the Fourier series representation, non-zero Fourier series coefficient or the harmonics, we can easily comment. Okay. Now, how we will comment, guys? I will just inform you, just explain you. Just wait. First of all, just let me know whether you have completed with this table or not. If you already completed with this table, now just do reply, so that I will take examples one by one and we will see in the examples which criteria are going to be satisfied. Do reply, bachcho. Shall we go for next? Yes. So, let me take one more one example here. Let me take the example here, guys. Now, voice is clear, I think. So, now student, I am making a curve here. You should tell me whether it is even signal or odd signal. Okay. Just let me know whether this signal is a even signal or odd signal. Okay. So, if my signal waveform is just like this, so here student amplitude is plus A and here the amplitude is minus A. Here we are having 0, t by 2. Here the signal, the time duration is t by 2. Here we are having total t. So you should tell me first of all the given signal x2 is voice is not clear. Neeraj, whether he just confirm beta whether voice is so less or what. Sound is very less, sir. Sound is clear or not? Whether to reply. And just let me know the signal is even or odd first of all. The signal is even or odd, Neeraj. Voice is clear now. Nupur Kumari. Voice is clear, sir. Okay. Now, whether you do reply whether this signal is even signal or not, we can hear you when the volume kept high. Right now, voice is clear na? Right now, voice is clear na, bachcho? It is even signal. Yes, shabash. So, first of all, student, by observing the signal itself, we can say that the signal is symmetrical about the y-axis. So, it is 100% an even signal. Okay, sir. Now, due to this even signal, Fourier series will contain only cos harmonics, that for sure. And because it satisfies the even symmetrical condition, so we are 100% that Bn is 100% 0. Bn is 100% 0. Now, my next question to you, whether it satisfies any criteria from the last slide. Whether it satisfies any criteria from the last slide. At t equal to 0, the signal containing plus a amplitude, and t equal to t by 2, the signal containing minus a amplitude. So, 100% it satisfies the amplitude criteria, sir. And due to amplitude criteria, we will say that this signal is a HWS signal only. The signal will be a HWS signal only. It means, my dear student, what should I write here? If the signal is a HWS signal, then we can write the signal is even signal as well as HWS also. So, it satisfies what, guys? It satisfies even symmetrical condition as well as HWS condition also. It satisfies even symmetrical condition as well as HWS condition also. Now, it means what? If signal is HWS, its average value will be always 0. So, because the HWS is there, HWS will make your average value 0, and HWS will also make all odd harmonics, all even harmonics 0. So, will contain only all odd harmonics only, containing only odd harmonics only. We can say that contain only all odd harmonics, containing only odd harmonics, contain only odd harmonics, contain only odd harmonics. Are you getting my point, guys? Yes. So, student, because of HWS condition, its A naught value 0. Because of HWS condition, now the non-zero Fourier series coefficient will be what? Now, the non-zero Fourier series coefficient, coefficients will be A1, A3, A5, A7 and so on. Even, sir, Bn is already 0, sir. Bn is 0 for all n. Bn is 0 for all n. We can also say that, sir, here An is also 0 if n is even, if n equal to even. I hope it is clear to you. And also, sir, A naught equal to 0. And if you want to comment on the harmonic, you should say that Fourier series will contain only cos harmonics of bolo only odd harmonics of cos term, only odd harmonics of cos term. I hope this part is crystal clear to you, bacha. I hope this part is crystal clear to you. Whether you just do reply. So now the signal satisfy even plus HWS also. So the signal is even plus HWS because of the even symmetrical condition Bn is 0, and because of the signal satisfy directly HWS also. So HWS will make average value 0 and also even harmonic 0. बोलो बच्चा लोग समझ में आई बात? Shall we go for next, sir? So this example number 1 I think crystal clear to all. Now I am going for the example number 2. Now I am going for the example number 2. Okay. So you should make the diagram for the example number 2, guys. This is my example number 2. This is my example number 2. Yeah. So this is my t and this is my x of t. This is my t and this is my x of t. So if my signal waveform is just like this, if my signal waveform is just like this, so this is the waveform A, this is the amplitude signal A, this is minus A. Now you should tell me, my dear student, this is my signal x of t with respect to t. Now you should tell me one thing, this signal is even or odd? This signal is even or odd, bacha? The signal is even or odd? The signal is 100% odd, sir. Now tell me it satisfies which criteria? So you will get to know, sir, here we are having positive edge. You can say that, sir, here, this is the edge, sir. So we are having this positive edge, and here we are having negative edge. And this is 0, this is t by 2, this is t. This is the fundamental time period, yes or no? So you can say that, sir, at t equal to 0, we are having a rising edge of plus a magnitude, and here we are having a falling edge of minus a amplitude. It means it satisfies the edge criteria, and because it satisfies the edge criteria, the signal is also HWS, sir. Now signal satisfy HWS as well as the odd signal symmetrical condition. So according to the coefficients, as far as Fourier series coefficients are concerned, what you will say, the Fourier series coefficient or the non-zero Fourier series coefficient, the non-zero Fourier series coefficient will be what, guys? Because the signal is odd, its pakka an will be 0. An will be 0 for all n, and bn will be also 0. Bn will be also 0 for n equal to even, yes. And for Bn is not equal to 0 if n equal to odd, yes or no? It means Fourier series will contain only B1, B3, B5, B7 and so on are the non-zero Fourier series coefficients. Because the signal is odd signal, and because the signal is HWS also, its average value will be also 0. Because the signal satisfies the HWS condition, its average value, its DC value will be always 0. So that is why it is 0 only. I hope till now everything is clear, bachcho. Just do reply fast. I think till now everything is clear, pyare bachcho. Just do reply fast. Chaliye. So if I will write the Fourier series representation of xt, it will be like this only, ki sir b1 sine of omega 0 t plus b3 sine of 3 omega 0 t, b3 sine of 3 omega 0 t plus b5 sine of 5 omega 0 t plus and so on. Yeah. I hope this part is crystal clear now. I hope this part is crystal clear now. Yes. All of you guys, just let me know, shall we go for next? So B1 sin omega 0 t, B3 sin 3 omega 0 t, B5 sin 5 omega 0 3 and so on. A0 equal to 0, average value 0, B1, B3, B5, B7 and so on. Now student, if I talk about what about the Cn value? So don't you think we have Cn is imaginary or real? Tell me why. The Cn is imaginary or real? Exponential Fourier series coefficient will be real or imaginary? Exponential Fourier series coefficient will be imaginary because the signal is an odd signal. Because the signal is a odd signal. बोलो बच्चों, बोलो हाँ या ना, yes or no, yes. चलिए, so now this question is also clear to you. It satisfy as criteria, but we don't write here as. This is our short trick. This is our short trick. Examiner will only say how many Fourier series and harmonics are present or how many non-zero Fourier series coefficients are there. Shall we go for next beta? चलें आगे, चलिए. So now I am going for the example number 3. Now I am going for the example number 3. So all of you tell me in the example number 3, the signal is even signal or odd signal, or this signal is HWS or not. You need to identify. Okay, you all need to reply. Now if this is a signal, so here we are having plus A and here we are having minus A. Here we are having 0. So this is my signal x of t. This is my signal x of t with respect to t. Xt with respect to t, yes. Now tell me this signal is satisfy which symmetrical condition, whether this signal is even signal or odd signal or HWS signal. Tell me its Fourier series representation. Its Fourier series representation satisfy what? Do reply fast. So tell me the signal is even or odd. So of course the signal is odd signal because it is symmetrical about origin. It is 100% an odd signal, sir. It is 100% odd signal, sir. And do you know here is t by 2, sir. Here is t by 4, sir. Hai, here is 3t by 4 and here is capital T. So this is all about the fundamental time period. This is till here you have fundamental time period capital T. So 100% the signal is odd signal. Now tell me, is it HWS or not? Is it HWS or not? Yes, sir, it is HWS also because it satisfies slope criteria. Here the slope is A upon this t by 4 and the same slope negative here, this distance is 3t by 4. So this distance is t by 4 and magnitude is also minus A. So because it satisfies the slope criteria, so we will say that the slope is our short trick, my dear student. You need not to write and you will not have any options in the gate. You will have option in the gate ki the signal containing HWS or not. Then tell me Fourier series contain what? Then the Fourier series will contain the same, sir. Average value A0 will be 0, AN will be 100% 0 for all n, and Bn will be 0, Bn equal to 0 for n equal to E1, and Bn is not equal to 0, for n equal to odd, So this is what our observation by just observing the diagram. By just observing the diagram, we can comment on the following. We'll also comment that Fourier series will contain only, tell me guide was, Fourier series will contain only odd harmonics of, Fourier series will contain only odd harmonics of sine term. Fourier series will contain only odd harmonics of sine term. Is this crystal clear, bachcho? Fourier series will contain only odd harmonics of sine term. Is this crystal clear? Fourier series will contain only odd harmonics of sine term. Sine term, it means the Fourier series representation can be look like this. Again the same I am writing B1 into sine of omega 0 t, where omega 0 is the fundamental frequency. B3 is the sine of 3 omega 0 t. This is the third harmonic frequency. Similarly, student, you can write B5 into sine of 5 omega 0 t and so on. Yeah, this is. Shall we go for next now? Clear, sir. Chaliye. Now I am going for the next example, example number 4. Okay. You should tell me example number 4 satisfy which criteria? Okay. Whether it is even or odd or whether it is HWS or not, you should reply. The signal is x of t with respect to t. So tell me guys, this signal satisfy which criteria? Tell me, the signal is a even signal or odd signal, or the signal satisfy which criteria? The signal is a even or odd, or HWS or what? Just let me know. The signal satisfy which criteria? All of you guys just do reply. Fourier series contain what? Its Fourier series representation contain what? Do reply fast. Okay, Vedesh says that nano. Okay. Why nano, beta? The signal is odd signal for sure. Why odd? Because it is symmetrical about origin. Because after that this nature, and after the below that this nature, in the left hand side this nature, this nature. So signal is symmetrical about origin. The signal is odd signal for sure. The signal is odd signal for sure. But is it HWS or not? It is a question. It is HWS or not? Very good, Vedai. It is not HWS, sir, because it is T and it is T by 2. It is also minus T by 2, it is minus T. So at T equal to 0 we have a slope, but at T equal to T by 2 we have an edge. So we don't have such criteria where at T equal to 0 slope, that at T by 2 should also slope. So 100% it is not HWS signal. So it is not HWS, it is only odd. It means it is not HWS, it means it is only odd signal. Only odd signal, it means the average value will be 0 for the odd signal. AN will be 0 for all n, and Bn will be not equal to 0. Bn will be not equal to 0 for all n, not equal to 0 for all n. It means Fourier series will contain only, it means you can write Fourier series will contain all harmonics of, not this time odd, all harmonics of, this time odd nahi hai, all harmonics of sine term. All harmonics of sine term. Is this clear, bachcho? Yeah. The statement is crystal clear to you. I hope this is part clear to you. So this signal is odd but not HWS. Very good, beta. Whether not HWS. Very good, bachcho. Just do reply fast. Shall we go for next? All of you guys, just let me know. Shall we go for next? Shall we go for next, bachcho? Yes or wait? जल्दी बोलना पड़ेगा आपको. नेक्स्ट और वेट? नेक्स्ट. चलिए. So student, now student, I am just adding whatever symmetrical condition we have discussed till now. Now I am just adding here hidden symmetrical condition. Okay. In the hidden symmetrical condition, what we can do? We can make or we can add or subtract any DC value. So by adding or subtracting any DC value does not affect the harmonics of Fourier series. I am just repeating my sentence. It means you can provide amplitude shifting to the signal waveform. You can provide the amplitude shifting to the signal waveform. It only affects the DC value. It means it only affects the average value. It does not affect on the harmonics. It does not affect on the harmonics. I am again repeating my sentence. Suppose that, let me take this example only. This is a pure odd signal. It is not hidden symmetrical. It is a pure odd signal. So that is why its average value 0 and Fourier series will contain only odd harmonics of sine term. Now tell me what will happen in the next example. Tell me guys what will happen in the next example. If I will make the next diagram just like this. So now you should tell me guys, if my question is like this, I am just making the last diagram itself. I am just making the last diagram only. Okay. Chali. So the last diagram is just like this, sir. Now this is my diagram, guys. 0, and this is my 2a this time, 2a this time, and this is my x of t signal, and this is my t signal. Now tell me, according to the diagram, now tell me this signal satisfy which symmetrical condition. Now tell me the signal satisfy which symmetrical condition. Come on. The signal satisfied which symmetrical condition. Come on. Is it satisfy any symmetrical condition now? Now a normal student will reply ki sir, no sir, it is neither even nor odd. It is neither even nor odd, sir. Yeah. But I am telling you, is there any scope of hidden? Is there any scope of amplitude shifting? And after providing amplitude shifting, is it satisfy any criteria? Just do reply. Hidden odd, kya baat hai beta. So this is the condition, my dear student, hidden odd condition, hidden odd, sir. It is not directly odd signal. It is not directly odd signal. It is a hidden odd signal, because if I will provide a amplitude shifting with minus a, if I will provide the amplitude shifting of minus a, or if I will subtract the minus a signal from this signal going to be downward, shift downward. So this point intersecting at A, now after shifting this point intersecting at 0, the signal will become odd signal. After that, after doing amplitude shifting, if the signal is satisfying odd condition, then actually it is hidden odd symmetrical condition. And hidden odd symmetrical condition always have A naught equal to non-zero. Always have A naught equal to non-zero. Because you are providing amplitude shifting, it will only affect the average value. Harmonic will not affect. So what is the answer? A naught is not equal to 0, but still the Fourier series will contain all harmonics of sine term. It means still an equal to 0, guys. An equal to 0 for all n. An equal to 0 for all n. Yay. I hope it is clear to you. In the last diagram and this diagram, what is the difference? This is pure odd condition, pure odd symmetrical condition. So that is why A0 is also equal to 0 and Fourier series containing all harmonics of sine term. Yeah. But this time, because the signal is hidden odd, so that is why, because this time the signal is hidden odd, so what we will say, the A naught value is not equal to 0, sir. A naught value is not equal to 0, sir. But all the harmonics, A naught is not equal to 0, but all the containing all sine harmonics only. Will contain all sine harmonics only. Will contain only all harmonics of sine term only. All harmonics of sine term only. Every student just do reply fast. Shall we go for next? Every student just do reply fast. Shall we go for next? Just do reply fast. Just do reply fast. Bolo bachcho bolo NOW. Shall we go for next? Chali. Now I am asking one more question to you, beta. Tell me what about this? If you are able to identify this, then tell me what about this? This time I am expecting correct answer from you all. Yeah. This time I am expecting correct answer from you all. This is my A amplitude, this is 0. This is my T. This is my T by 2. Tell me this signal satisfy what? And the Fourier series contain what? Tell me. I am expecting correct answer from you all. Neeraj Kumar, Vedai Singh, I am expecting correct answer from you all this time. Neeraj Kumar says that even signal. Is it a even signal? Is it a even signal beta, yes or no? Not equal to 0. क्या बात है वैसे? Sir, it is a pure even signal. It is a pure even signal, pure है. Even signal pure है. But it is a hidden HWS signal. It is a hidden HWS. Why hidden HWS, बच्चों? Because if I will provide the A by 2 shift na, then the signal will be look like this. Okay, I will just make a rough diagram for you. If I will provide the amplitude shifting na, then the A by 2 shifting na, then the signal will be look like this, Oh, the signal will be look like this. Yeah. So this is my amplitude A by 2. This is my minus A by 2. So now if this is xt na, this is the signal of xt minus A by 2. But what is the good part? As far as harmonics are concerned, harmonics will same for xt as well, xt minus A by 2. Yes or no? It means xt minus A by 2, if it is a yt signal, let me take it is a yt signal. So yt signal and xt signal both are having the same harmonics. Only DC value will make the difference between xt and y2. Only DC value will make the difference. Because if the signal is yt, its DC value is 0. But my original signal is xt, so its DC value is not 0. Its DC value is not 0 because it is hidden HWS. So what we will say that its A0 value is not equal to 0, sir. But its Bn value is 0 for sure because it is an even signal. So Bn equal to 0, and even it is a HWS also. So An will also be 0 when n is even. If n equal to even, and An is only non-equal to 0 if n equal to odd. So if you are looking for the non-zero Fourier series coefficient, examiner is generally asking for non-zero Fourier series coefficient. However, it is whatever you are solving right now, it is a gate question. Okay, I will solve this. I will show you. It is a electrical 2011 gate question only. So the non-zero coefficients will be A0, A1, A3, A5, A7 and so on. Bn will be all 0. Bn will be all 0 and A0 is also not equal to 0 because it is a even plus hidden HWS. Is it clear Vedai now? Is this crystal clear bachcho? Just do reply pyare bachcho. Is this clear? Shall we go for next? Chaliye, I am expecting correct answer from you all. I am waiting. I am waiting for your reply. Come on, come on. Chaliye. So now I am writing one more example. Now I am making one more example. You should tell me whether it is an even or odd, or it satisfies with symmetrical condition. Okay, you should tell me. चलिए सर, बताते हैं सर, आप बताते हैं सर अभी. Dash dash dash. Okay, चलिए. So ये dash dash dash. Okay, dash dash dash. चलिए बताइए, this signal satisfy with symmetrical condition. This is a periodic signal x of t with respect to t. It is minus a. It is my 0. It is my t by 2. It is my t. It is my minus t by 2. And it is my minus t. Tell me bachcho, this signal satisfy with symmetrical condition. Come on. This time I am expecting answer from you all. Beta, Neeraj, satisfy with symmetrical condition. Come on. The signal satisfy with symmetrical condition. Come on. बोलो 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 बोलो. Whether he, Neeraj has already replied. Whether he better do reply fast. Whether he reply that any no nano. Oh ho ho. So what about the Fourier series? Whether it is HWS or not? Not HWS. Okay, voice is low, sir. Nani, voice is low. Am I audible or not? Whether he, bolo beta bolo. Chali, I think audible. So, dear student, the first of all, very good observation. The signal is a nano signal only for sure. Shabash. It is neither even nor odd because it is neither symmetrical about y-axis nor symmetrical about origin. Sir, मैं पहली बार आपकी लाइव क्लास कर रहा हूँ सर. Very good, नीरज बेटा. Very good, very good, very good. Attend all the live classes, okay? Attend tomorrow also. We'll meet at morning 11. चलिए. Do reply fast. If the signal is a nano signal, if the signal is a nano, the signal is nano. Why? Because the signal is neither symmetrical about y-axis nor symmetrical about origin. Now it's very clear, sir. Very good, beta. Now it's clear. Now it's clear. Now it's clear. Now, shabash. So it is a nano signal. Now tell me whether it is HWS or not. So student, can you please tell me it is satisfying any criteria at t equal to 0? What is the slope? At t equal to 0, the slope is a upon t by 2. And at t equal to t by 2, the slope is minus a upon t by 2. So it satisfies the slope criteria. It satisfies the slope criteria. So that is why this signal is a nano signal, but it is a HWS signal. And because it is a HWS signal, it is a pure HWS signal. It is a pure HWS signal. Ankit Majumdar, slope criteria. Kya baat. So because it satisfies slope criteria, so it is a HWS signal. So HWS will make your average value 0. HWS signal will make your average value 0. And it will also make your AN equal to 0 for n equal to even. For n equal to even. But AN is not equal to 0 for n odd. Yeah. Similarly, this also will make Bn equal to 0 when n even. But Bn is not equal to 0 if n equal to odd. Yeah. It means its Fourier series will contain odd harmonics of cos also and odd harmonics of sine also. Bolo हाँ या ना बच्चों. So you should write a note that the Fourier series will contain, very important note, its Fourier series will contain, you should write, its Fourier series will contain, its Fourier series will contain, its Fourier series will contain odd harmonics of both cos and sine, of both cosine and sine, both cos and sine term, both cos and sine. Yeah. All of you guys just do reply. Shall we go for next? Shall we go for next? Pyare bachcho, just do reply fast. Shall we go for next? Bolo na yes or no. Now I will show you the gate questions also. Now I will show you gate questions also. Okay. But before that, I am asking one more question to you. Tell me guys, for this question. Tell me, for this question, signal satisfy which harmonic condition? Come on. Okay, like this, like this. Dash, dash, dash. Okay. Complete the diagram, guys. Complete the diagram with me. All of you try to complete the diagram. Dash, 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 dash. Here the amplitude is A. Here is 0. Here is T. Here is T by 2. Yeah. बोलो बच्चों बोलो. Yes. Come on. This is T by 4. This is 3t by 4. है ना? This is minus t by 4. Minus 3t by 4. This is exactly at the midpoint t by 2 minus का. Like this. Exactly at this point we have minus t like this. बताइए जरा फटाफट. This signal satisfy which condition? The signal is even or odd or what? The signal is even and satisfy half wave symmetric or not? Tell me. Ankit Majumdar. Do reply beta. So Neeraj Kumar says that the signal is even signal. Whether he do reply. All of you guys try to reply fast. All of you guys try to reply fast. So this signal is a even signal for sure. First of all, the signal is a even signal for sure, 100%. The signal is even signal because it's symmetrical about y-axis, so it is a even signal. Now tell me whether it is HWS or not. So now check at t equal to 0 exactly when you will check, we'll have a decreasing slope nature of this. Yeah. And at t equal to t by 2, we have the same signal which is having the rising slope. Here falling slope, rising slope. Negative slope, positive slope of the same magnitude. So because satisfy the slope criteria, it is HWS also. So now Fourier series will contain what? The Fourier series will contain 100% A naught value will be 0, A naught value will be 0, and Bn value will be also 0 for all n. For all n, Bn value will be also 0. And if I will write An equal to, if I will write An equal to 0, then you can write n equal to E1, n equal to E1. But An is not equal to 0 for n equal to odd. So you will say that the Fourier series will contain only, you will say that the Fourier series will contain only, Fourier series will contain only, बोलो बच्चों बोलो, only odd harmonics of cos term. बोलो, is this clear to you? The Fourier series will contain only odd harmonics of cos term. Is this crystal clear to you? Fourier series will contain only odd harmonics of cos term. Is this crystal clear to you? All of you guys just do reply fast. Shall we go for next now? Very good, beta, very good. Now it's time to solve some gate questions. Okay, now it's time to solve some gate questions. The condition we have completed. Now this. Tell me guys which option is correct directly. Can you eliminate any options? Can you guys eliminate any options? बताओ जरा. It is a continuous signal. Okay, it is a continuous signal. Yeah. Now can you please tell me which option is correct? Can you eliminate 3 options? It is a 100% odd signal, sir. It is a 100% odd signal plus HWS also. Odd plus HWS मतलब containing only odd harmonics of sine term. Odd harmonics of sine term. अच्छा, इसका मतलब एवरेज वैल्यू ये है 0. एवरेज वैल्यू दे रखा है इसमें, दे रखा है. ये भी रॉन्ग है, ये भी रॉन्ग है. एवरेज वैल्यू दे. Only option number D for Delhi not having average value because it is odd and HWS. Its average value for sure 0. Correct answer option number D for Delhi only. हाँ ना? Just like that, if you have a good presence of mind, if you know the concept, this is a pure conceptual question. You can directly eliminate the options because of the symmetrical condition. I hope this is clear to you, beta. Vedai, Raj, Neeraj, Ankit, Nani, do reply fast. Come on, tell me for this gate question. I will show you the options. First of all, you should observe the diagram carefully. After that, I will show you options as well. I will show you options as well, bachcho, do reply. All of you guys just do reply fast. बोलो बच्चों बोलो. Tell me which option is correct for this. Tell me for this gate question which option is correct. Come on. EE 2011. EE 11 which option is correct? Come on. Which option? Which option? Are you saying that option number D for Delhi? Asking for non-zero, so A0 and AN are equal to 135. So are you asking for option number D for Delhi? Whether he option number B. B is not correct, beta. It is B में तो A1 से लेके A2 सब आ रहा है ना. You are saying that odd value of n, that is why D for Delhi na. You are saying correct, A0 and AN for odd value of n are non-zero. Then option number D for Delhi, yes. It is D for Delhi. Correct or not, Vidai? Correct or not? Chaliye. Now it's time to solve this question, guys. A signum function is given to you. Those who don't know the signum function representation, examiner has also given the signum function functional representation. So everybody, we know that the signum function is nothing but, I am making a small diagram, at x is greater than 0 pe plus 1 and here is minus 1, just like this. Just like this. Bolo bachcho haan hai na? Yes. So if the signal is x of t here, it will containing plus a, it will containing minus a, it will contain like this, 0 se leke like this. Yeah. Now the Fourier series expansion of the signum function of cos of t. It means what? If I will make a curve like this, if I will make a curve of cos t first of all, I need to make a curve of cos first of all. If I will make a curve of cos of t, then what will happen? Just try to focus. So this is my cos curve, guys. This is my cos curve. Yeah. If this is my cos curve and this is my signum function of cos. So this is my cos of t, this is my cos of t with respect to t. And here I will make the curve of signum function of cos t. Here I will make a curve of signum function of cos t. So like this, guys, yeah, like this. Like this. Now tell me, if I talk about the signum function nature, now my signum function of x is what? I am just writing here. My signum function of x is what? My signum function of x is 1 when x is greater than 0 and x is less than 0, it is minus 1. Yeah. So if I will replace x with cos of t, if I will replace x with cos of t, I am writing here. So if signum function of cos of t, then functionally it will open like this, ki whenever x is greater than 0, here x is cos t. So whenever cos t is greater than 0, it is plus 1 and whenever cos t is less than 0, it is minus 1. Yeah. So if you are looking for signum function of cos of t curve, yeah. The signum function of cos t curve, it means whenever cos t function is greater than 0. So at this place cos t function is greater than 0. So for this the signal will containing plus 1 value. It means for here the signal will contain plus 1 only. After that, whenever cos t is less than 0, it means cos t is less than 0 here, the signal will contain minus 1 value. Signal will contain minus 1 value. Here also plus 1 value, here also minus 1 value, just like this. Ye minus 1, here also a plus 1, here also a minus 1, here also a plus 1. So now you can say that signal is plus 1, here is plus 1 and minus 1 value. Now tell me the signal satisfy which? Now this signal satisfy which symmetrical condition? Signum function of cos t. Now of course the signal function of cos t, you can say that the signal is a even signal, sir. The signal is even plus HWS, sir. The signal is even plus HWS, sir. The signal is even plus HWS. The signal is even plus HWS. So now you should tell me, guys, which option is correct. You should just read the options. The Fourier series will contain, because the signal is even plus HWS, Fourier series will contain only odd harmonics of cos term. It means which harmonics? 0. So here the only cosine terms of odd harmonics actually written in the option number D. Only cos term with odd harmonics. I think it is not visible to you. Option number D for Delhi correct. Shabash beta. Here also option number D for Delhi. Only cosine terms with odd harmonics number. I hope this part is crystal clear, beta. Just do reply. Just do reply, bachcho. Yes or no? Yes, sir. Whether he option number D. Chali. Okay, guys. So today, due to technical glitch, we have started late session. So that is why we are ending at 12:30. Tomorrow we will meet at morning 11 a.m. Okay, and we'll continue the Fourier series problems, gate problems based on the symmetrical condition. And after that, we will discuss the Fourier series properties as well, and we'll also discuss the exponential Fourier series. We will also discuss exponential Fourier series. Okay, chali. And we'll also see the property based questions, simple property based gate problems based on the Fourier series in the upcoming classes. Okay, bachcho. So that's all from today's class. Bye bye. Take care. We'll meet on tomorrow. Okay, bachcho. And those who are looking for the complete structure gate preparation, you can just enroll yourself in the zero fee program. In the zero fee program, you need not to pay anything. You just need to enroll yourself, and after that you will get the free access of our test series. You'll also get the free access of our chapter test, subject test, and also some live lectures free of cost. Student, those who are looking for the complete gate preparation for 24-25, once you will join the IMS Gate Academy, whether in online or offline, you will get 800 plus live lecture access. You will also get the dedicated doubt solving portal. You will also get 26 to 30 hard copy of books. That is nothing but theory book and exercise book, which will contain 4000 plus practice questions. Also, you will get 130 plus test series, which will contain chapter test, subject test, multiple subject test, as well as mock test. Okay, प्यारे बच्चों. So that's all from today's class. मिलते हैं हम tomorrow morning 11 a.m. Okay, bye bye. Take care. The zero fee program link is given in the description, guys. Okay, chali, bye bye. सर आपका क्लास लेकर मज़ा आ जाता है. वेरी गुड बेटा, वेरी गुड. थैंक यू.